Hello everyone, my name is Steve. I want to welcome you to my YouTube channel where you will find Commodore 64 and Atari programs available here. It will be basic and assembly language programming. You might be asking right now, why am I showing the Atari emulator and the Commodore emulator at the same time here? Well guys, due to some requests I've been getting recently, I decided I'm going to try to go both ways if this is even remotely possible. Basically, I'm going to be taking Atari programs and putting them up in an emulator display for people to see them. At the same time, I'm going to be trying to still work in the Commodore stuff. I know I'm kind of pushing myself to a limit here, but I'm getting questions on it. People want to understand more examples. They appreciate the videos or whatever, and I didn't want to leave you guys in the dark thinking that Commodore has gone its own way and Atari is in the dust, but it's not true because I still like both of them. So I actually have an example here of a display list with the Atari down here, and this more recent program I'm working on the Commodore. So I'll put the Atari away for right now. We'll come back to that in a later session. Right now I wanted to show you a program I've been working on for the last few days here. It's not complete yet, so we'll probably go through and fix it as I run it, but I'll show you when I run it what it does here, just for example. You'll see the little arrow going down the screen there. If anybody's ever seen or been in the area of the Atari, you would know something about typing games. They had a lot of typing emulator type games in those days. I think I can pull up an example and show you here in a YouTube video. Watch this. Well, actually, you know what? We're going to skip that because I don't want to get knocked for any copyright third party. But there was one by Alan Alda. I think his name's Alan Alda. The guy from MASH, was it? Alan Alda, how do you say that name? And he hosted a commercial back in the 1980s for a typing game that was released by basically a teenage, I think he was a teenage programmer, maybe in his 20s, and he was new to the scene, but he entered a contest that Atari had back in the days, and they were looking for a real prime example of something that could teach people, kind of like an educational, and utilize graphics of the Atari and speed, sound, and all those things at the same time. So he designed a Typing Attack. I think it was called Typing Attack. Let me go back in, just review it. Pretty sure it was a Typing Attack or something like that. And this, I would like to be able to show you, but if you want to see it, just go to that YouTube channel you saw there and you can watch it. And it would basically emulate the keys on the screen. So you see right here, I have keys set up here as an example. So he laid across keys that would change, I think, on timing, and you'd have to type them in, and when you type and press a key, you'll see me do it here in a minute. I'll hit the H key, and it'll shoot up at the thing that's coming down at you. Now in his example, he had little aliens kind of scrolling and rolling down the screen here. I just stuck a little arrow kind of falling from the sky. It's not positioning correctly though, so I need to make it position over each individual letter. But I did get it working pretty good now. So if I press Y, it'll shoot from the Y. There's actually two Y's there. I noticed that. I need to fix that. There's a B. If I hit the V, it'll shoot from the V. But if I try to press something like the C key, it won't work. If I press the D, it won't work. E, it won't work. F will work because F is still on the screen. So basically, it's corresponding to the keys you're seeing on the screen here to shoot this little thing coming up at the screen there. You notice my score is changing even though looks like nothing's really happened yet, so we'll probably need to fix that up in the game here too. But I wanted to show you the code, so those who want to see it, you are looking at a Commodore multicolor sprite that's coming down the screen here, and this is just an overlay of text in the background. Basically, there's no special tricks to it, there's no interrupts, so if I stop it here, you'll see it's still not going to keep scrolling or anything like that. It's just a simple basic program responding to basic code. So let's go ahead and have a look at that. And get right back there. So the other thing I wanted to teach you in this video, which is what I'm trying to do at the same time, I'm going to try to come up with like a utility program or maybe a little small game like I did here and teach you some of the concepts along the way. The important part about this is I wanted to teach about arrays before I started designing this myself, and I was going to go into trying to use some kind of program to teach you about arrays, and then I got carried away and said, hey, why not make my own little modified version of the original Typing Attack. So I came up with this little short piece. So we'll get started on it right here, right away. So the first line you want to take notice of here after the remark statements, and of course this is just a print screen to clear. This just changes the background color. So going to line 15 here, you'll see it says dim, and then you'll see, remember we learned about, if you watch the other videos on C64 functions, you'll learn about the functions I've got here on the screen. This right here is actually what's known as an array. And this is just telling how big the array is going to be. It's 26 in length. And this is another name for an array, ls. Another name, lr, and vl. The 26 is corresponding to 26 letters in the alphabet, so I just kind of left it at that. Now let's teach you about what an array is. Now if you run the program here, or run the program here, if I utilize an array here already, there's nothing actually in that one. Let me see if I can find one in here. So I'll probably have to run it again. Okay, let's see if I can run it, run stop, and go back and try to hopefully print out an array here. Kind of searching for one that would be in memory. There's one right there. So you're seeing what it's doing is it's storing 1050 in memory here. And what it's doing is it's taking the value, a numerical value, and sticking it inside of an array. So if I wanted to change that value for location 1, I just said VL1 and then equal to whatever value I want to change it. Let's say I want to change it to 1051. Now it's going to store 1051. Now if I type in VL1, you'll see 1051 is in it. Now another thing nice thing about arrays is you don't have to make up a whole new variable name like you would if you were just making up a variable. If you had like a VL, you might have to do a VL2, a VL3, or whatever. In this example, you can just go to the next element in the array, which would be 2, and just kind of go from there. And I'll show you before I even destroy that there's actually something in 2 right now. Actually, well, though I thought there was. Okay, so there's not. We'll store something in there. I'm just storing screen values to show you. So if I print VL2, now you'll notice it's got 1200. So if we print both of them, you'll see that each one is corresponding to the values I stuck in there. So the nice thing about this is you can make a huge line of arrays, and you can store information into them. You can retrieve it later. You can transfer values, copy values. It can be used for a lot of really cool things. One time I took a bunch of array values and I actually was playing, I think I had a game running in the background or something, and it was positioning stuff on the screen and the player had to pick it up. I kind of made like a demo later where it would just repeat what happened earlier, and it would just kind of backtrack where the player was at and, you know, move them around or whatever. It's because it was remembering the exact positionings which I stored in the arrays for that movement. So anyways, the next line here I wanted to show you, real simple. This is, if you learned from the C64 function, this is just a single variable array, what's called a string array. And if I type it in lns, assuming I just erased it, looks like I just erased it there. So I'll have to run it again, sorry. Every time you try to type enter over a line and you try to print that value, it's going to be gone. It's just going to initialize it back out. So you see right there, it just drew a line down the screen. If you run, when I run the program, you'll see it down here. This line down here is just printing that ln. So if I just print ln, you'll see it. It's basically all I did is I just kind of positioned it, which will show you what the next line does here. It does the positioning. We're almost there. Actually, excuse me. This is something you may or may not be aware of. This is actually known as the timer in the Commodore 64 system. So if you type in TIs and kind of go like this, you'll see it changing. So you can use this to keep track of the clock in your computer, and you can always reset it by putting in the zeros there. You saw me put in the 6 alternate zeros. So okay, line 30. This one right here, as I mentioned earlier, this is taking the line and positioning that lns. Remember, that's just that line we drew up here earlier. And it's taking it from position, which is known as the vertical position, 17. So it counts down from 1 down to 17. And then it sets it on line 0 over here, so we can just draw that line singly across at the 0 line. And then the next line here, 214, 19, kind of moves it over a little bit more, and it's going to jump down 2 more lines and print the word score and have the variable SC after it. Now when I run it again, you'll see it here. It's right here at the bottom. So position, this line is at 17, and this one is at 19. So 17, 18, 19. And it just kind of positioned where the score is going to start at, which I think was 12 again. Space is over. Let's go back there. Yeah, that's what it was. Okay, this next line here, again, if you go back to my C64 functions, this one will be a little bit more helpful, because this next line is actually known as a numerical array, and this is basically taking a value and storing it into this LT variable. So let me list that to show you what exactly that's doing right now. We'll kind of set it up in immediate mode so you can see what happens. Right there, you see 22? Now watch this. As I go through it, you'll see it changing values, basically. I have to kind of erase them so you can see what they are, but it's storing what are known as random numbers in between 1, this starts it off at 1, to 26. So it's going to pick a number between 1 and 26, which is any letter that would be conceived in the alphabet, basically. Let me see if I can erase that space afterward here. Yeah, it's still not going to erase it. I tried another video to get the spaces to erase, and I still could not, for the life of me, get them to erase, so I have to kind of show you there like that. Okay, so that's keeping track of a letter between 1 and 26. And the reason for that is because I'm using I'm using the Commodore screen memory, and I want to be able to pick a value that's an LT, so I'll show you if I zero it out here. Let me kind of erase the top screen so you can see what's going on here. I'll watch it up here when I put it in. Now when I hit enter, you'll see it right there. Now watch. See, it's changing at the top there because it's picking a random letter in the alphabet. So that's how I got the random alphabet letter to start, so we could put the random letters on the screen. Well, apparently sometimes there's duplicates are sneaking back in. Something I'll probably have to work on later. Okay, so that's what that line's doing. This next line here, I know this one is still in use. I need to probably remove this, but this right here, TM, is keeping track of the timer. It's another special numerical value for the clock. I'll show you right now. If you hit TI, you'll see 9089. I think this is counting in milliseconds or something. I forget how you would say that. I think it's milliseconds. I could probably, pull out the Commodore book and look it up here. But let's just say it's just a clock in your computer that's keeping track of times down to the very little seconds there. So, and it changes rapidly. I think if you take the TI divided by 60, I think it gives you a more accurate number. Yeah, I was right. It does. It gives you more of like a decimal component there that you can kind of read. So, I think it's in seconds, if I'm pretty sure. Okay. So the next thing here is we're obviously storing this into the TM variable. So whatever is in TI is just going to be stored into TM. That'll be used later in the program. Actually, I haven't done that yet, but it's in there. Okay, so the next thing here, you'll see this line that says go sub 2120. Let's go to that line right now. 2120. Okay, so what you see here is what's called a for next loop. And if you already know what those are, it's basically just going to count from 1 to 8. And each time is A going to change 1, A is going to be 2, A is going to be 3 until it hits 8. Now while it's counting in between here, you can do some things in between. Now notice I did stick that letter thing in here again because we're going to be utilizing it to change it as we're displaying that to the screen. When you saw those numbers moving across the screen earlier, this is exactly what that line is doing. So look right here at the next line. Not to confuse you, but this is another for loop inside of one, so it's actually known as a nested loop. So this nested loop is necessary so we can grab all 26 letters of the alphabet, make sure that we're grabbing the accurate one, which is what this next line does here. Now I'm going to skip this line right now because this line won't make sense to you until you get down to the line down here. Remember, this is just a next. So this is keeping track of all 26 letters. After all 26 have been conceived here, it's going to store them in an array. Remember we learned about arrays earlier, called LS, and it's going to store it in A. If you look up here at the top, A is 1. So the first time this goes through, it's going to have a 1 in it. It's going to set it equal to that random letter that we chose. You can see what it says there, save letter. And it's going to keep going through that each time, changing this to 2, 3, and so on. Now let's go back up here again. Now this line here I mentioned was a nested loop, counting from 1 to 26, which keeps track of all 26 letters of the alphabet. Now remember, because we stored it down here, the computer now knows which letter is in this array. So up here, we're going to be checking what letter was that this line down here picked up. So let's just say it was the letter B. Now this line is saying if LSX, somewhere in this loop here, in this whole LS array area, from 1 to 26, is equal to a letter that we selected up here, then we're going to need to randomize that letter. So basically it's saying, did you pick this letter already? Because the first time you pass through this loop, nothing will be in here because we haven't stored this yet. So that's why I kind of stuck this up here to check for it later. So once you come down here later, it'll jump back up here because it's still keeping track of this whole A loop, which is the next is down here, way down here at the bottom somewhere. Okay, like I said, this is going to be a little bit more of an advanced program, but it does teach you about arrays because remember, it's just storing everything in memory numerically from this variable into this array to keep track of which letter we're selecting. And if you remember up here what I said earlier, this is just picking a random letter. It's going to store it and it's going to check it to make sure that there's no repeats going on. For some reason I'm still getting repeats every now and then, but that's just something I'll have to look into. Okay, the next line down here, you'll see it says RN equals 1705 plus SK. Now this 1705 is just referencing a screen memory location, and I could show you by, let me just poke it on the screen here real quick, and I'll come back to that line. Poke 1705, comma 30, I think 30 is the arrow, right there. So basically, if I do it again here, you'll see it's basically referencing this point on the screen here, which is exactly where my letters begin, and you saw them drawing out on the screen here earlier. I'll run it to show you it real quick again here. Right here, this is 1705 moving across, drawing the rest of the letters in sequence, basically, across the screen. So let's go back down there again. I'm going to move down a little bit further here. So what this is doing here is it's poking those letters to the screen. Remember, this is the random letter here picked up earlier to show exactly which one needs to be there. Now I think what I might be able to do to fix this is maybe set this to the LS array, and that might fix it, because LS is the one that's preventing the repeats. I'm almost curious to try it right now. Let's see if that'll, I probably won't know if it's really going to stop the repeats, but we'll see what it does. Seems to be a little bit faster too. Okay, that time it looks like we got no repeats. Let's try it again. It's definitely a lot faster. I think I might have fixed it right there. Let's see. Okay, wait till Sprite moves out of the way so I can see it. Okay, so T, Y, H, V, Q, G, U, K. I don't see any repeats there. D, I, M, T, V, Q, S, C. I think I might have fixed it. So that's what it is, because it was picking up the random variables, but earlier it was just drawn in that letter, but it could actually end up picking other equals or other identical letters because it's not keeping track of or comparing them anywhere. So anyways, let's get back down here. Okay, so this line, like it says, drawing out those letters on the screen. Now we've stored it in the array. We know exactly which letter is going to show up each time. And that's, you just saw now, one of the advantages to learning to learning how arrays work, because you can use them to compare what's going on in those elements to do other things like that. Okay, now this next one is another array I'm using. I think VL, I just used that for value, and this one is a letter something. I forget, letter skip or whatever I called it before. VL for value. It's going to take the value again here in A because it's counting from 1 to 8, and it's going to store in 1050 plus SK. Now, the reason why I originally did this is because, let me show you right now what 1050 screen memory is all about. Because I originally had this working without Sprite, so I was using the characters to draw that, move that arrow down the screen, and I just used a character arrow. So I'll show you it right here. Right there, you see that arrow? Or wherever the down one is, I don't know. It's 27 or wherever it is. But basically, I was moving that one down the screen instead of having the Sprite until I decided to finally add the Sprite. So that's what that was doing. So that's probably in use right now and not of any use to us. But we do need to modify this to actually work with the Sprite, so I could store in the Sprite data here so that we can position the Sprite in appropriate corners. Because keep in mind, a Sprite, when it's moving across the screen, has between 0 to 320, I believe it is, but it actually goes all the way from 0 to 512. but it flips over at the high bit when it, or the most significant byte when it hits the 255th byte to add on the next carry or whatever to the carry flag. So we're going to fix that here in a minute, but the sprite is different, as I was saying, I was going to mention here, than the character data, because the character only goes from 0 to 40, while the sprite can go from 0 to 512. So that's a big difference in comparison or contrast. Okay, so now that you're getting used to the arrays, look at this one. It says if LSA equals 1, then we're going to do something. Now I need to explain this one to you. The LSA equals 1. Remember earlier, let's go back and look at what actually you can see it right here, but let me pull this down a little bit more so you can kind of see from the very beginning. Kind of move down here so you can see where we'll stop right at the 8 part right there. For A equals 1, where I showed you earlier, to 8. Right down here it says if LSA equals 1, that means if you look back here, remember we stored LSA and we kept track of the letter. So this is just saying what value came up in here. So if it's a 1, that actually represents the screen memory for an A character. So this means that now we found the A by a random search or scan, whatever you want to call it. Shuffle, I think I called it here. And then what it's going to do next is it's going to store another and create a new array, which we did mention earlier, called LT. Take the first element of 1. Well, it's not the first element. There, you can actually start them at 0, but I just put this 1 just so it kind of matches with the 1 that's over here and the 2 and 3 and all that. So it makes sense basically. And this is saying is equal to 10. The reason why I put a 10 and why you're going to see all these weird numbers down here is these numbers are representing the key codes that are responsible for showing that letter. So that means if memory location 203 is equal to 10, then that is showing the A. And this one here just goes down, and if you look here, well, I'll come back to the LR in a minute. If you look down here, it says 2. This is going to be the B, and memory location 203 is equal to 28. That's the B. I just basically went down and wrote down what each letter represents and how it's being picked out of the memory location when the key is being pressed, the interrupt is being responded to show you how to keep track of which letter you're pressing on the screen. Because later, I use this array. It's going to sound a little more complicated, but I use this array to kind of compare a loop inside the array against each key value, so I know exactly which letter is being pressed at that time. There's kind of a trick. I had to play with it. It took me all day yesterday to really get this thing working, but I did finally get it working. And that's why you see you can only press those letters that you're seeing on the screen only because it's checking for them each time here in the loop. And remember, this is up here scanning for 8. So this is actually scanning 8 letters on the screen because you saw only 8 going across. Remember, you saw 8 down here at the bottom. And then this is 26 letters in the alphabet, so we can read every proper character to make sure we get a good random value for each one. Okay, so the next thing you're seeing here says LR1 equals RN. Now remember up here earlier, I said this is going to change later. This is actually keeping track of the position of each letter on the screen. And I did that originally because instead of having the sprite, let me run the program and show you what I originally had going on here. Okay, let's wait for the letters to go on the screen. Before the sprite comes down here, if you look here where the letters are, right above them, in line with this, I was basically having a character fall down on each one of these. So you might have seen a little arrow falling down here, but it wouldn't have been a sprite. It would have just been a regular character graphic until I decided to upgrade it with the sprites. And basically that was just another way I was testing it when I was first trying my own typing example until I decided to, improve it with the sprites. And that's what this was doing originally. So right now this really isn't of any use, but it's basically originally kept track of the proper location of each character in that corresponding location, and then I could randomize them and move them around on the screen basically based on these values. I won't go into that right now because it's not being used, but just remember all these LSAs are scanning through 26 letters. That's what this A does. It'll scan through a 4nex from 26 letters to get each appropriate scan, and it's going to check each one here for A, B, C, D, E, F, G, H, I, J, and so on, all the way to the 26 letters. Now let me put the rest of the screen out here so I can show that to you, or the rest of the listing. And again, these are just the key presses for location 203. We'll come back to the LT in a minute. I'll show you how that works. Okay, so right after here, we get to the last one. And then you see this SK equals SK plus 5. Originally, I had this just moving the cursor over a little bit so it would pick up the next position. Basically, it was only moving the arrow around on the screen, which originally was just a character arrow, not a sprite. But that's probably going away too, so we're going to have to get rid of that because I made those modifications. And then you see return here, so it's going to go back to the end of the loop where the ghost sub was earlier. And let's fix ourselves to go back there again. Right here, 2120 is where we left off. So now we're going to go to ghost sub the 3210, and let's have a look at that line. Okay, so down here you see the only thing 3210 is just taking a variable called NP and set it equal to integer random 1 times 8. That's basically just picking a random number between 1 to 8. Let me demonstrate that line here. I like to do things real time now. I think that's going to kind of help people to see the picture better. See, it's just picking a number in between 1 to 8. Well, it's actually 0 to 8 because I didn't add the 1 on it. Eventually a 0 will pop in here, but if I do it long enough. Now another thing you'll notice here is this int in front of it. Now if I take this off, for those who might be wondering, what it does is it casts a decimal value into this now. Now it's still going to pull the number, but after it's going to show the remainder. I think this is by the power or however they calculate this. And that's how you get rid of the decimal, is just add the int in front of it. And that clears up and gives you a single value again. Because we can't really work with decimals. I mean, decimals will really work with unless you're doing some kind of math equations or something. But in regular programs like this, int is a very powerful thing. No, it's known as an integer, which became common later for C++ and all those other things. So let's go back here to where that ghost sub was again. And go to the next line underneath it, because we're done with that ghost sub. Remember, we just returned and we came back to the next line here. Because every time you do a ghost sub 2120, you hit a return, it just goes back here again. And it goes to 3210, return, it comes back here again. So now, an equivalent, that would mean we're at the 4500. So let's look at 4500, which is the sprite reading into sprite data here, basically. So all this is doing is just taking 0 to 62 in a for loop. So basically all this data down here, these are 62 bytes, and it's reading each one in SP. That's just picking up each letter here. Each time you go through a for loop, SP means it's going to read the first one. It goes through this, it pokes in the value. This is poking into the appropriate sprite data register so that we can see the sprite data on the screen. And then this SP is going to read in the value, so it goes back here to the next A, which will now be 1. SP will now be 220, and it just keeps going down the line like that until it's done reading everything in. And this whole location's 122.88 plus 62 will hold all this data, and I'll show you how to print that out if you want to see it for yourself real time. You just basically take A equals 0 like you're seeing. You're basically replicating what you're seeing up here, except now you're going to peek into this memory location so you can see what's stored there. 122.88. And you say plus A here so it knows. Like up here you see plus A, except it's poked. So it can basically tell you what's going on there. And then you kind of close it off like that. I do these two quotes at the end so I can stick a comma in the center here and kind of concatenate it together. And I do a next, and you'll see all the same data in this data statement, except now this is looking in memory locations, and it's able to read the sprite data because it's pulling this directly out of the computer's RAM. So let's go back to these lines again so we can kind of go back over them again. Wherever they were, what was it, 4210? 4500. Okay, so the next line here, you see poke 53, 248, 100. That's just positioning the sprite basically horizontally at 100 position. Horizontally is this direction. And this one is vertically, so vertical is up and down. This next one, 53269, 1, is what, I think this is the one that enables the sprites. The 53276, 1, I believe that's the one that turns on multicolor. To be politically correct here. I just realized I lost my Commodore 64 book. Oh, it's way over there. Let me go grab it. It's right over here. Okay. So this one, I've showed this before. Actually, you know, I've got the wrong book. I'm looking for the mapping to Commodore 64, and I grabbed the system guide. This is the one I wanted to show you, was the mapping to Commodore 64. So basically, if I go ahead and look up this register here, 53276, I can tell you what it is here. 3 seconds at least. It's Sprite multicolor, so this, I was right, this activates as multicolor, and this one enables the Sprite. And these are the colors. 53286 is the color register for one of the bits in the Sprite. Let's see what it says here. Sprite multicolor register 1. So this would be 2, and this is, well, let's see, 1. Well, wait, there's 5. Let's see. Oh, it's 0. There's a 0. Okay, so I got this backward. This is 5, the 0, 1. And I noticed I had this one in there twice. Didn't catch that right away. So we don't need this 14 because it's going to read the next one anyway. So let's just go down that one. So this is basically 0, 1, and 2 registers. So it can change those colors. I showed that in another video. It basically just allows you to change those bits inside the Sprite. If you want to see it, I could show it to you anyway. We can just go to that line alone and it should do the trick. Right there's the Sprite data. And now that we just go to 4515, I'll list that on the screen here. So I'm going to kind of erase this a little bit. List 4515, was it? Yeah. Now I'm going to show them real time here. I'm just going to kind of poke them into memory. And then we'll change them as we go through here, and you'll see the Sprite colors changing as I change them. Just the kind of people who are curious about it. See it change the background there. And you'll see that they're basically changing wherever the Sprite data falls at. So I just kind of changed the data like that. So that's what that does. It changes the Sprite. Okay, let's clear that. The next thing here, we're going to get into the heart of the program here. So line 150 kind of gets into what's called the main loop. Remember I mentioned earlier about the keyboard being stored in memory location 203. So that's just keeping track of the keys that are coming up in KY. If you want to do a test though, you can do something like this. I usually just start with line 1, print 203, and you just go to that 1. And you press the keys here, and they'll change based on the value. So A, remember what I said earlier about A? A is 10, B is 28, and C is 20. D is 18. So let's see. We got 10, 28, 20. 10, 28, 20. I wanted to show you something. 10, 28, 20. Look down here. 10, 28, 20. So basically that's just keeping track of A, B, C. It's just keeping track of those key presses that are going on in the program. So let's erase those and move back into where I said. Okay, now that we've got the keyboard here, the next thing we're going to be doing is we're going to be building a loop around this so that we can scan all 26 letters of the alphabet, because we never know which letters exactly are going to appear on the screen, so I just scanned all 26. So inside of this, I do have a score keeper going up on the screen here to keep track of the score real time. This is basically positioned at 19 lines down, 18 over, and SC means it's just going to show the variable. It doesn't do anything else there. The next line down here, you see a peak. This is what I was telling you about earlier. Peak 203 equals LTA, then go sub 2010. And the 2010 is where it's going to fire the bullet. So what I was telling you earlier is we stored all that. If you remember, we stored all those values that were being picked up by those key components inside of the array called LTA, so that we know exactly when that letter is showing which letter is being corresponded to that letter. And that's kind of how I did it. It's kind of a trick. I just made the computer store the values and then kind of compare them against, well, I basically, I checked the letters that were coming up in that random array, and then from there, once there was a match on that, I knew I had found those keys, and I just stored the appropriate key codes in. That's how I got this to work. Like I said, it took a little bit of trial and error, but that's basically what it does. It's just going through an array here. Now if we print the LT array, for those who want to see it, I'll show you. Assuming I didn't erase it here. Let's test it here. We'll find out in a minute if I erased it. We're going to go through all 26 letters here. I'm just going to print out this array. You just do the LT array, and then I'll just set a comma so you can kind of see them separated by a comma. And it looks like I erased it or something. Let's run it again. It should all be stored by the time this gets started. Okay, now I know they're in there because we just reproduced the letters on the screen here. So let's go back to the program. Hopefully print them out successfully this time. I know they're in LS, but I wanted to see if they're going to come up in LT. There they are. So you see the 14, 21, 34, 42, and 17, 33. Now if you look through here, A, B, C, D, E, F. So this is basically saying at this location in 14, what value is showing up here. I need to look up my key chart. I realize I just didn't now have it with me. I wrote these down yesterday all on a key chart. I hope I know where I put it. I mean, I know just by looking at the codes what they are, but I wanted to show you the key chart. And by golly me, if I can just find it, I'll be happy. And sometimes my videos can be a little bit disorganized. I'll come up to something and say, oh, you know, I forgot to do such and such. But nobody's perfect, right? So let's see if I go through this mess here, I might be able to figure out where I wrote all these at. Maybe I stuck it up here somewhere. Maybe I wrote it over here. Trying to see if I stuck it on a piece of paper somewhere. But, I mean, that's basically what those are doing, is they're keeping track of the key codes. But I can't seem for the life of me right now to figure out what I wrote them on to show you anything at the moment. On all these extra papers, and I don't see anything on them. But you saw me earlier when I ran and I poked in the locations 203 that those were picking up the appropriate key, so we know that that's how that's working. I just wish I would have been a little bit more prepared to thought that I was going to show this. But you never know what you're going to show in your videos until you actually run them, and sometimes they just don't turn out the way you want. So I might have to skip on from that. I'm only going to look a little bit more here. But let's see what this paper shows. There's nothing on that. Well, I guess we're going to have to skip over that. But I wanted to show you all those key codes that were being scanned into memory. The only way to show you is what I showed you earlier by printing in the peak 203 and doing the 1 and all that. That's what I was going to show you, is how each one corresponded to the alphabet. But if you want to see them yourself, just do that little test. Oh, print peak. Just do that little test there for lines 1 to 2. Like that, and run it. You can stick it at the beginning and just press the keys and you can kind of see what they're related to. So we don't really need the paper for now. Well, I wish I knew where it was. I think it's way over there and I can't even reach it. Actually, it is over there. I wonder I didn't see it. It was all the way across the screen here. Right. I'm going to add a little bit extra light in here so we can kind of see this. So I wrote them down here, down the page. You can kind of ignore all the other stuff here, but you'll see. I'll just bend it in half and show it to you. So look down here, down the side there. You see where it says A, 10, and right above it says peak 203, B is 28, and right there beside it you see 1. That's the screen character for A. 2 is B, just like I showed you. The 20 is the peak for 28, or 20 is for C. The 18 is for D, 14, and so on. You just basically write out the letters you want to use, and space is 60. I'm not using it there, but and return is 1. But that's basically how you make the Commodore read the keys. And I just tricked it into saying which location was showing. So if we randomly pick the letter A, then that means we are pressing peak location 10. So it corresponds to that correct key. And again, that's just how I did it to kind of trick the computer. So, but it worked. So you did the job. Let's go back here to turn back around here. So I don't have to show you all that now. But you kind of see that's what I was trying to iterate what this line is doing. If peak 203 LTA, it's scanning those keys, matching them. And once it has a match, it's going to be able to fire the bullets on the screen now that we've got the appropriate key press. And that's what this line down here is doing. This one's going to be a little bit more complicated. It's actually a lot less complicated than it looks, but if you look at it, it looks pretty complicated stuff here. Actually, we don't need these first two lines because these used to be regular peaked locations, and I removed them. Actually, now that I think about it, I don't think I need any of these because I was originally just making it position the lines again and drawing them down on the screen, but this is actually still drawing the up arrows that shoot up on the screen. So let's run it again and I'll show you. And then there's our letters. These are the LS variables being stored. LS1, 2, 3, 4. And then what you're seeing here is when I press a letter like P, hold it actually, you see a little arrow going up on the screen there? Let's see if I can continue it so you can see it again. Right there, the little arrow right there is being represented by that other line I was just now showing you. So it's an ASCII character being coded into the screen for screen memory, and it's being poked. Where's it at? Right here, fire bullet. Let me go back to 2000. And it's poking these locations here, LRA. And the reason why is because now I realize why we saved the LR. I said it wasn't used earlier, but it is actually because it's keeping track of which area screen memory is showing on the screen at that appropriate point. And it's kind of shifting the position each time to move it around every time a hit is received. So let's go back down here and I'll show you the LR again right here. This is keeping track of location 1705, which keeps track of the firing position from each letter and is storing that into appropriate array there. And it's being used up here later to position, or down here, to position those arrows that you're seeing shooting up the screen there. Now the reason why I said this was complicated, you'll see the minus 40 times L, and you're probably thinking, what the world is that? Basically all this is saying is when you first position this letter by its appropriate place in memory, because we stored it in an array, we want to subtract 40 from it so that it'll keep going up the screen. And then we subtract another 40 times L because it's still rising up the screen. Now I could originally just erased all this, but I originally had other things going on with this. I think I had one dropping and rising or something, if I can remember correctly here. So basically, it's just positioning the letter. I'm pretty sure, I'm almost afraid to lock it up. I'm pretty sure if I take this out, it'll probably still work. Because it's basically just subtracting from that 40 location and moving it up the screen. And this right here, 40 times 6, is keeping track of, I notice that value is different than that one. Probably don't even need that. Let's see, poke LR plus, this one says 30. Oh no, this is the color screen memory. So I got double data going on here. I don't think I need this first one because we only got one arrow moving up the screen. I think I see what I did. If when you run the program again here, or when I run it and shoot a letter, I'll show you. Let's press K for example. You'll see that it's changing each time as it goes up the screen from blue to yellow. And that's what I did is I had it make it look like it's flashing up the screen. That's probably why I put that in there. I probably had other reasons, but that's what it turned out to be. Is the first line here will flash the character A, and then this will set the color, and then this will turn it off. So and this is just basically flashing right here, 40 times 6. It's flashing every other 6 position or something. And it's just basically how I got that flashing effect working. So this right here is just clearing it. 32 means show a space in there. And that's all this is doing again, is just keeping track of the first line to erase the appropriate arrow position. So this PL comma 66. I believe this is positioning the line on the bottom, but I'm pretty sure. Let me see if it actually still shows there. Actually, it's this line above the D, because originally I was only testing the D, so we don't even need that line. I could just erase it. It's not being used for anything else, so I'll just erase that one. You saw that little yellow line above the D there? It's being represented by the other line here. I'm just going to erase this PL, comma 66, and we should still be good to go. Yeah, it still works fine. Okay, let's go back to the program. Okay, so right after we got that done, we're going to go sub to 3210 once we first fired the first bullet on the screen at the letter in the appropriate position. And again, if you remember the 3210, it's setting that MP equals in it, so it's picking 8 numbers and for the MP between 1 to 8 and sticking them in the variable NP. I almost forgot why it's doing it. Oh, right here, because it was originally positioning that on that character location. So I was originally, I don't know, I was doing other things with it. I can't even recall right now, but I changed all that because you see me put a remark here, so I turned all these lines off here because I'm no longer using that. So instead, look at the next line here, poke 53249, comma 20 plus MV, and this is the line we'll probably have to change. This is positioning the sprite on the screen that you saw horizontally, which means I can stick it way up here because it starts at 20, and it's going to keep adding MV to it each time it moves down the screen, and MV is increasing by 3, so that's how we get the sprite coming down the screen at a pretty appropriate speed. And this MV is greater than 17. Make sure that the sprite is still moving down the screen, but it doesn't go beyond 170 position. Let me run that and show that to you right now. And I'll position the sprite and show you. First we'll watch it, and I'll show you when I change that variable what's going on. I can see it went to the queue, went a little farther down. I probably need to fix that. But if I poke 53249, comma 170, you'll see it's positioning right into the letter there. So if I add another 3 to it, that's probably why it went below the line. Like that, and you're seeing it go down, drop below the line. I don't want it to go below the line. I want it to basically once it hits that letter, wipe out that letter because you weren't fast enough to type it. Because remember, it's a typing program, a typing game. Okay, so let's go back here to our area. Okay, so I think I went too far down here. Let's see, position letters randomly. I showed you all that stuff, so 2000. Right there in the fire bullet. Okay, so once we positioned it here, this is the data I was trying to play with earlier. I was just basically saying poke 53248, which positions that arrow and moves it around on the screen. Because you notice it was moving, but it's not moving by the letters because we need to position it. And I was trying to use this to position it based on wherever that letter screen code was falling, but I couldn't get the math right. I was trying to multiply it by 4 plus 15. It's better just to position it itself, which we could do here in a minute. And this ms equals ms plus 10, it's just adding to it to move it over 10 positions. Actually, no, this is being used by the score. So this is just trying to keep track of how fast you were hitting that letter. If you weren't pressing it fast enough, you got 10 points, or you didn't get 10 points. I was trying to make that work too. Probably something I need to fix too. And this returns just to bring it back to the original line, to bring us back into our main loop again here. Let's go back there. We're just about done with everything here. And we're going to implement those changes. Okay, so I think I am pretty much done with the loop. Because I positioned, I go step to 2010, so after the letter is fired, this goes down here. And this, yep, this is what I showed you earlier. I kind of jumped around a little bit, but this is still staying inside the same loop here, the main loop. The position, that sprite going down the screen, which I did explain to you already. And this KY equals 60 was originally used for the space bar, but I can remove this. I don't need this anymore. It's still just going to fire a letter when I press the space bar, but it's of no use. I was just originally testing the animation or the movement for the screen character as you press, you press a key and the arrow goes up. originally only if you press the space bar would it only respond to that key and move the arrow. So that's how they got to work. Okay, so that's kind of the gist of the program here. So let's go back, and what I'm going to do is I'm going to run the program right now, and I'm going to do some tests to try to figure out where these sprites are hitting at, where it's going to hit at in its vertical location or its horizontal location each time, so we can position it into the right spot each time. So right now, I could probably peek into it and see what's going on with it. So it's at location 100 right now. That means this is positioned from here, way over here, 0 to 100, and this would be the 100th line, which isn't exactly on the V, but it's pretty close. So we'll come back to that 100 position in a minute. Now I'm just going to kind of play with some values here to try to get it to where it's positioned over each individual letter here. This shouldn't take a whole lot of time, hopefully not. I'm just going to kind of do some guessing here. So 50 is right there. Let's move it down a little bit too so we can kind of see it closer to the letter there. Maybe up a little bit more. Down a little bit more. Let's try 155. That's pretty good. Okay, so now we're going to test the horizontal position. So 155, I said that was, what I have, 40 or something in there. Let's just try 20. Maybe 25. 25 is pretty good. I think I'll use 25 for the first value, so I'm going to go ahead and just make a note. Write that down on paper here for myself. So I'll put a 1 beside it. Pen's not working. Okay, I got a pen here. Hopefully it'll work. Okay, so we got the first one is going to be at 25. So we got 8 of them, so I'm just going to number them 8 here. Okay, so that's location 25 horizontally. So let's just kind of figure out where the next one would hit at. Oops, had an equals after it. A little too far, it's probably at 70. Maybe it's 65. 65, looks like this is going to be an even kind of thing. So 65, and I could probably do my math here right now. If I just subtract 65 from 25, I could probably hit the next position right on. So 40. So it looks like I might be skipping in between 40 each time. Let's see if that's right. Yep. So skipping over 40, so basically all I have to do is just add 40 each time, and I can kind of see where it's going to hit each time. Next one will be 150. Oh, that one didn't go a little, maybe it was 145. It's 145. My math was a little bit off. Okay, so 145 plus 40, 185. That would be the next position. 185 is the R. Okay. We're going to go off the screen and we're going to eventually have to make it figure out to change the most significant byte here. So 185, I think this is going to go right off right here. Let's see. I don't think you're going to be able to add 40 to this. Oh, yeah, I can. Okay, so 185 plus 40. 225. Okay, so this is going to be the last one that's off the screen there, or the last two or something. So we know 255 isn't going to do it. If I put 255 here, it's not going to be long enough. Yeah, it doesn't quite reach it. So what we do is we're going to set that most significant bit. As an example here, 53269, comma 1. So now it's set to the next location, and we can now move into that where it would be at. So poke 53248. Remember, it's just going to start back at 0 again. Did I do this right? Oh, it's 64. I had the wrong one. I was wondering why it didn't move. Okay, so let's see, 15 maybe? 15's too far. It's probably 10. It's 10. Okay, so 10's pretty close. Actually, there's 9 letters, aren't there? 1, 2, 3, 4, 5, 6, 7. No, there's 8. So I got 1, 2, 3, 4, 5, 6, 7, 8. Seem to be missing a letter here somewhere. I don't know. Okay, so the next one would be plus 40, should be 50. Okay, Good. Well, it's pretty close, but not exactly. But we'll leave it the way it is for now. Now I'm going to take these values I created here and I calculated, and we're going to store them into an array. We don't basically need to do anything else, just store them into an array. You can read them into a data. I'm just going to store them numerically so I can kind of show you real time what's going on, so you don't have to kind of see any more maybe confusing examples. I'm just going to start, try to find a safe place here. 22 will be good. And we'll just start storing them. I hope they all fit here, but we'll see. So we're going to store these Sprite data into the array. I'm trying to see where my Sprite data started at here. Let's go back and list the program to see where the Sprite was moving at. This is the Y location. It's down here in the fire bullet. So it was the... Well, we don't want to overwrite the LTA because we're already using that for other things. So we'll have to set up a new... I guess we'll have to set up a new array here. So we'll just add it right here. SP. And then we've got 8. Because there was 8 that we're going to need. Okay, so then we got that. Now we're going to be able to set... I could start it at 0 because I do start at 0 if you want to see that. Just for example, I'll start it at 0. And we're going to create them here now. Hopefully this example will really help you see how arrays really work. That was my goal here. Even if we don't get the program done, I want you to see it for yourself. So you can actually go in and utilize it for your own benefit. Okay, there they are. Now we have them. Now all we need to do is position them and randomly pick the position that the sprite is going to hit at each time. Or we could just increment through each one, but we want to make them do it randomly so it doesn't look like it's just picking any other position. I think that's what 3210 was. The goal 3210 right here is just picking a random number between 8. So when we go to this line each time, it's going to be able to pick that random position. So let's just remember 3210. So each time it hits down at the bottom, I go to 3210 here, which is right here, right there. So after it picks the end, then here's where we're going to be able to change it. So 2042 is where we're going to store the new data for the NP. So trying to see how I was going to do this. Okay, actually no, I just need to do it up here, I think. Let's see. 53248, 53249. This is the movement. I need to change the... I'll probably have to move this other position. Because what I'm trying to do is affect this area right here, because this is storing the horizontal sprite. So we don't need all this junk after it. But we do need to move... No, we don't. Right there's where it hits the MP. It creates a random value. We can store it right here. So MP, or MP, SP, with the value that we chose from NP. Because remember, NP, if you go down here again, don't get confused by this. Look at 3210, and I'll put 2050 on the same line to show you. So we go to NP. Let's do this actually. 3210, 3220. Where is it at? 3210. 3300. So 2050. Okay, so right there's what I wanted to show you. So NP is picking a random number between 1 to 8. I did show you and demonstrate that earlier. It picks a regular number because of the integer taken off the decimal. And then once we get that, we're going to move the sprite into the appropriate position, because remember, we created data in here earlier that was positioning that sprite across the screen. Now the only thing it won't do is position the far sprite. We'll have to make it check a value to say, if you equal this position, we need to move that most significant bit up. So we could do that, but for right now I'm just going to show you for the first part that it should work. because that NP should pick the right value each time. It's going to pick 8 locations. The only thing I need to do is test later whether a position has been eliminated, but it's just still in trial. So let's just see if that part will work for now. Looks like it's working. It's hitting the I. So if I hit Z, press Z, it should move over. Hit the Z. Hit Y. It should be positioning randomly across the screen. There it is. It's working great. Because it's keeping track of that array. It won't show it until it goes all the way. It looks like it should already went there. There it goes. Just seems to be running a little slow. I do the I. And it's just moving it around based on those sprite positionings that we set up on the screen in memory. It just won't move it to the far screen here because we haven't, like I said, we haven't programmed this one for the most significant bit yet. But we can. We might have a little bit of time here. We're a little bit over, but let's go ahead and have a look, see if I can put that together very quickly here. Okay. So right in here is where it does the NP. So it's going to need to check that number. I think it's 8 or 7. Let's test it real quick. Okay, let's run this again. Okay, let's go up here. Let's poke the position, 225. I think I moved this off the screen or something. Let's see. Right there. So it's actually got 2 more letters it needs to do. So once it hits 1, 2, 3, 4, 5, 6. So once it hits 7, it needs to set that most significant bit because that means it's gone beyond the screen coordinate. So here's how you do it. At least hopefully we'll get this right. Just go to the fire bullet routine. And right above this line that we created earlier, we can do something like 2046. We'll kind of squeeze it in here. I bet you, let's just squish this one down. I usually squish them down like 5 lines and just kind of use the other line since we used it already. Okay, so now we have room for 2050. So we're saying 2050 if NP, which is a random value, is greater or equal to 7, then poke 53264, comma 1. That means that we've hit over. Now the other thing you need to do is check that it's gone less. So if NP is less than 7, let's see, less than 7, then poke 53264, comma 0, and that should work. I'm going to save this just to make sure I don't lose any of my program for any unexpected reasons. And those do slip in from time to time, so I don't want to go there. Okay, so let's run it and test it. You're seeing programming in action. So eventually, once we hit that location, I'm pressing Y, but it's not working. I don't know what's going on here. Oh, I'm not activated to the screen over here. There it goes. So let's just keep pressing until it gets over there. Aha! Now we're over by the S. Might take a little while, but we'll probably eventually get to the R. Or it might be stuck over here now. Let's see. Nope, it moved over. So it's keeping track of where the NP is each time. There it goes. Seems to be stuck on the S, but you see it's moving across the screen now, where before it wasn't. So it's working the way we want it to. It'll switch once it gets down there. It's supposed to. There it goes. I know it's not very pretty because it's like, why is it that the arrow moves up while the sprite stops? Yeah, it's still stuff we'd have to work with in the program. I could have fixed this by doing some pretty fancy assembly language, but I wanted to make it really simple for people. And basically all it's saying right now is if you don't hit that letter fast enough, you're going to lose on points. So that's the whole point. And you have to kind of hold the key down. It's not immediate response. So it's kind of slow in a way. Just because BASIC is slow itself. But like I said, I would have speeded up with assembly, and I could have made this far better, but didn't want to make it too complicated for people. So, but it's working. I guess we're going to call this a night. This has been quite a long one, but I hope you enjoyed this session. Like I said, I'll get back to the Atari stuff here later and kind of go that direction too as well. I'm going to try to get both going at the same time. That way I don't have to really boot up my Atari, pull out the Commodore like you see in the background here, or the Atari. I can kind of work from the emulators. Now I got that all working. So stay tuned. It's going to get really good. And definitely subscribe if you're interested. And I'll keep popping those videos out as they keep coming up to me and I keep getting the requests. Have a good one.